Hi guys, welcome to lesson 10.2b, Simplifying Radicals, part 2. Our objective for today is that I can simplify radicals involving products and quotients. Our essential understanding for this lesson is that you can simplify radicals using multiplication and division properties of square roots. So, problem number 4 is a word problem, and it says a door's height is 4 times its width, W. What is the maximum height of a painting that fits through the door? So start off with a word problem. We want to always start off with drawing a picture. So there's our doorway, and its height is 4 times its width. So the width is W, the height is 4W. We want to know what is the maximum height of a painting that is going to fit through that doorway. Well, that just looks like a right triangle, doesn't it, Miss Irzo?
It does look like a right triangle.
So we're going to use that that thing. What was that thing that we learned?
Oh, what is that thing? Somebody's theorem. That old guy.
Mr. Boland's theorem. There we go.
Yeah, older.
Okay. Pythagorean theorem. A squared plus b squared equals c squared. We're looking for the hypotenuse here. So we are just going to do height is equal to the square root of 4w squared plus w squared. Now, notice we put that in parentheses because the 4 and the w are both being squared in this relationship.
Chapter 7!
Yep. So 4 squared is 16, w squared is w squared, plus w squared. So we have 16w squared plus w squared. 16 plus 1 is 17w squared. And we can simplify that radical by bringing a w to the outside, because that's 17 times w, if we remember that rule. So w times the square root of 17 is our solution.
Do not use your calculator to find out what the square root of 17 is.
Yeah, just if it's an irrational like that, leave it as an irrational. Or sorry, leave it as a radical. All right. A boat traveled 3 times as far due east as it did due south. What is an expression for the distance the boat would have traveled in a straight line from its starting point to its destination?
East.
So we're going east, so we're going to the right.
South.
And we're going south.
Look what we've got.
Hey, that's another Pythagorean triangle, isn't it?
It is.
So we've got 3 times as far east as it did south, so we have 3x and x. A squared plus b squared equals c squared. Again, we have our 2 legs. We're trying to find our hypotenuse. So the distance is equal to the square root of 3x in parentheses squared plus x squared. So 3x squared is going to be 9x squared plus x squared. 9x squared plus 1x squared is 10x squared. And we can remove the variable from the radical since there are 2 of them. That's the square root. So we have x times the square root of 10. Okay? All right, now we're going to interrupt our math lesson for history. 1893 World's Fair had a replica of the Santa Maria, because it was the World's Columbian Exposition.
The Nina, the Pinta, the Santa Maria.
It also had a replica of a Viking longboat that was made and brought there. And in the background of that building, the background building there is the Museum of Science and Industry. That building was built in 1893 and is still there today. And I agree, that is one of the best movies ever.
It's one of the best movies.
Yep. And if you know what it is, you're cool. All right. Problem 5, simplifying fractions with radicals. The division property of square roots says that the square root of the fraction a over b is equal to the square root of a over the square root of b. So our example, we have square root of 36 over 49. We split that into 2 separate radicals. The square root of 36 is 6. The square root of 49 is 7.
Do not convert that into a decimal.
Yep. Stop right where you're at. Adiosa, stop right there. Hockey fans know what I'm talking about. All right, square root of 144 over 9.
Is that chiliosis chili?
No.
Oh.
Eddie Olczyk says stop right there all the time.
Oh, but I can go.
Oh, yes, you can.
I can go.
So, square root of 144 is 12, square root of 9 is 3, and we can simplify that fraction to 4. So we want a simplified fraction.
Shouldn't you be impressed that I knew who Chelios was?
Chelios.
Yeah, him.
Yeah. All right, square root of 121 over the square root of 81. Perfect squares. You've got 11 over 9. That's a going to just be a repeating decimal, so you don't want to convert it. Okay. Square root of 27x to the 5th over 48x. Mr. Bolin started to get mean on these.
Well, you do them a little bit different than I do.
Okay, well, show them your way.
$48. That's 16 times 4.
Mm-hmm.
So 4 is 2.
16 is 4 times 4.
Am I there yet?
I think you are.
Okay. And an x. Okay. So I pull this one out, and he comes here. And this guy is still left here. And I pull this one out, and he comes here. And I pull this one out, and he comes here. And this guy is left here.
Okay.
And then I can pull 1, 2, 3 of those guys out. So 2 times 2 times 2. I can pull out an 8. And I'm left with an x. And then
Multiplication property, you can split the 3 and the x apart. And you've got square root of x over square root of x, which cancels out.
So then I am left with 3x squared in the numerator over, I'm still left with an 8 in the denominator.
Should be a 4.
Uh, 2 times 2 is 4. 4 times 4 is 16. We'll have to come back to that one in a second and see what I did.
Okay. All right. You guys try letters D, E, and F on your own, and then we will go over them. So square root of 64 over square root of 169. Square root of 64 is 8. Square root of 169 is 13, 8/13. Square root of 225 is 15. Square root of 49 is 7, 15 over 7. So I think this one, well, this one we could just simplify. What I like to do, yeah, never mind. We'll do this. So we simplify the radicals. We have 12y times the square root of y, because 144 is a perfect square. 169 is the square root of 169 is 13. Square root of x to the 4th is x squared. And we just have that one remainder of square root of y in the numerator. Okay. What I like to do for a problem like letter C is I like to simplify things that I can first. So this is a different approach to it. Here, slide it down a little bit. So the first thing I did was I divided both parts by 3. So I did, so I reduced my fraction inside my radical. That's what I did. So I ended up with square root of 9x to the 4th, because x to the 5th over x is x to the 4th, over 16. And then I took the square root from there.
That was much easier.
So my, what I tend to do is I look to see if I can simplify inside that radical first before I try to do anything else. Now here's the thing, guys. There is no right or wrong approach on this. This is probably one of the more frustrating aspects of algebra because we're not going to give you, there is not one straightforward answer of this is the best way to do a problem. You have to look at it and evaluate it and make some decisions based on what you're seeing there. So you're going to have to look and see, do I have perfect squares right off the bat? If I do, then I want to take that square root. If I don't and I can do some division or some simplifying, that would be the best approach. So this is going to be involving a lot of your brain power. You're going to have to really think about these problems and put some logic into what you're doing. Okay. All right. Down at the bottom, problem 6, rationalizing denominators.
That's why, because we haven't learned the rationalizing denominators, and that's what I was doing. Okay, got it.
So rationalizing denominators is removing a radical from the denominator of a fraction by multiplying both the numerator and the denominator by the same radical expression. Your hint is that you want to simplify first if you can. Simplifying your radicals are going to be your best approach. That's my personal opinion. So we multiply by the square root of 3 over the square root of 3. Remember, doing that, we're just multiplying by 1. We're just changing the look of the relationship without actually changing the relationship. So the square root of 3 times the square root of 2 is the square root of 6 over 3. Because square root 3 times square root 3 is just 3. Okay?
Can't simplify.
Can't simplify, so we're going to multiply by the square root of 18m. And so we get the square root of 90m over 18m. Now, can we simplify that at all? Well, I'm going to guess the square root of 90 can be simplified somewhat. 90 can be broken up into the factors 9 times 10. And we can take the square root of 9. So we've got 3 times the square root of 10m over 18m. And can we reduce something there?
Whole numbers.
Whole numbers. So 3 and 18 can reduce to 1 and 6. So we have the square root of 10m over 6m. 6m. Okay. Letter C, I want you guys to try that one on your own, and then we'll go over it. So letter C, we're going to multiply by the square root of, so Mr. Rizzo first rewrote it as two different radicals, square root of 7x over square root of 3. We're going to multiply both numerator and denominator by the square root of 3. So we get square root of 21x over 3. Now here's something that you guys might look at and say, hey, we can reduce that to 7x, right? No, absolutely not. The 21 is inside that radical. It's inside a house. It cannot interact with anything that's not inside a radical. All right, so think about inside the house, outside the house. That'd be you can't be talking to somebody, you can't be interacting and reducing when they're in different places. All right, so letter D, multiply by the square root of 5, numerator and denominator, and you get the square root of 105y to the third over 5. Now the 105, I mean, we've got factors of 21 and 5. 21 is 7 and 3 and 5, so those are our prime factors. Doesn't help us at all. But we have a y cubed in there that we can take out a factor from. So it's going to be y times the square root of 105y over 5. And that's your reduced form, okay?
For every 2, 1 comes out.
Okay. All right. That's the end of our notes for today. Go ahead and make sure you fill out your level of understanding and write down any questions or concerns you may have from this lesson, and we will see you in class.